He will tell you, thank you. So have fun, and it's your stage, Robin.
Thank you. Thank you so much. Good morning. Hello. Hello, friends. I would like now to talk to you a little bit about humidity and moisture calibration. But before I talk about the product and the concept, I would like to talk to you a little about the reasons why we decided to develop this product. So we've been working for far too long in the area of humidity and moisture, and in all of these years it's been very difficult to find really good calibration solutions which are suitable for industrial applications. Laboratory systems are very good, but industrial applications have been very difficult. So we kind of came up with the idea to try and solve that problem. Second is, recent years there's been a much greater focus on the energy efficiency in industry. So, for example, in dry applications, the amount of energy that's used to dry a product or a material is extremely high, and with energy costs increasing because of geopolitical problems, energy efficiency has become very important. Another reason was the uncertain performance of humidity and moisture measurement devices. Those of us who have worked in this field for many years know that in certain kind of conditions, the sensors are not working very well at all. But unfortunately, there was no practical solution to be able to confirm that, so we wanted to find an answer to that. And there were no existing systems. So until this product was introduced, there was nothing where you could actually calibrate a moisture sensor on site, which meant it's very difficult for engineers to validate the performance of their systems without very complicated moving the product, sending it away, or going to a laboratory. So that was the motivation for the product, for developing the product. And then here's a big number. So between 12 and 25% of the energy used in industry is for drying. The source of this data is an EU project, number 723576, Dry Efficiency. Now, it's interesting how the range is 12 to 25%, because that means they probably weren't very confident with the values. So let's take the mean value of saying being around 17%. That's still, almost 20% of the energy in industry is being used to dry stuff. And of course, to dry things, you have to put energy in. You also have to measure how dry the gas or the process is. So that was a part of the big motivation. Now, typical dry applications, and now here you see some of the big, heavy-hitting dry applications. So battery production is a very hot topic at the moment. The water in the air and the gas surrounding the battery production means the batteries are less reliable, so you get lower yield, so you have reliability problems. So there's a lot of focus on measuring humidity in battery production. The compressed air industry, who provide the dry air to the battery, it seems to want to change on its own, by the way. They want to be able to confirm the quality of the air going into the drying systems. Natural gas, these big liquid natural gas tankers, the water has to be very low in order to be able to compress it and transport it. Specialty gases that are used for example, in semiconductor manufacturing. Then we have semiconductor manufacturing, and then there's heat treatment. These processes all require very dry gases. So in order to provide those dry gases, you have a drying system and obviously a sensor to control it. Now here's a case study which was provided with some help from a compressor manufacturer. And here we have an example of the cost of running a compressed air drying system. Now, the numbers you can see, the regeneration, let me just put the pointer. A typical PSA dryer, pressure swing absorption dryer, you have one drying column and you have a regeneration column. And this column is used then to dry the gas that's coming out of the system. Now, the cost of running a 300 liter per second typical industrial compressor is around 26,000 euros per year if you are working with a pressure dew point of minus 65. At minus 70, 28,000 euros per year, and at minus 75, 33,000 euros per year. So it's 33,000 euros just to run that dryer to maintain the pressure dew point. And minus 75 is a critical value for class 1 air dryers. So we made the calculation that if you have a 5-degree error in the measurement of pressure dew point in a compressed air system, the cost for that error for one dryer is 5,000 euros per year. 5,000 euros per year for one dryer, and there are thousands of these dryers all around industry, basically measuring the wrong value and controlling to the wrong value, because the sensors need to be optimized in order to work well in those kind of conditions. Okay, so how do we solve the problem? Well, the typical systems for humidity and moisture calibration are explained here. So you can use a calibration gas cylinder. So you buy a cylinder of a pre-mixed gas mixture, which you then apply to the analyzer. But these can be very expensive, difficult to handle, quite complex. You have to take them on site. But it's one way of doing it. Another very good way of doing it is to do a sensor exchange, which means that you take the sensor out and you replace it with one that you know is good, which is very convenient, very practical. The problem is you don't really quite know when the sensor stopped being good or when the sensor has had a problem. So you never really know whether the measurement is correct. Thanks for the automatic forward. Then we have moisture calibration systems such as the mixed flow. So we have a rack where we mix dry and wet gases to be able to calibrate the sensor. And then we have 2 pressure generators, which are laboratory-grade instruments, which are fabulously accurate. But both of these systems are, big and large and need a compressed air supply, so not very practical for use on site. So our concept, the FPG. The FPG is a little play on words. Frost point generator, because for us it's frost point, but most of the industry is using the term dew point. So it's a frost point generator, and we call it a dew point calibrator. And it's a portable system. So it's about 22 kilos. You can take it from the trunk of your car, go on site, check the performance of your systems. You need no external gas supplies or water supplies. It's self-contained and very easily adaptable for use on site. And it's a very precise system. It's based around the same principles as the 2 pressure generators, using temperature and pressure. So it's fundamental, SI traceable, high-level performance. And because of our experience in the field, we've made it so it's compatible with any type of moisture analyzers. So dew point sensors, P2O5 analyzers, all the different types of units that are out there. How it works is, for me, many years of thinking about this, very simple. In practice, it's quite complicated because of the way that the system has to be sealed, but we have a temperature-controlled condensing saturator, which is the heart of the instrument. And we flow the gas in the system, which is sealed, in recirculation mode. So the gas vapor pressure, the water vapor pressure in that loop, becomes equivalent to the dew point of the condensing saturator. So it's a condensing saturator. It takes the water out of the air above the dew or frost point. And of course, there are practical things required. So we have a circulation pump, flow measurement. We have a purge function for cleaning or over-drying the system if we need to. And we can also introduce more water into the system with an atmospheric purge. And then here we have the practical point. We have 3 sensor connection points. And we have a sample loop where you can connect to any type of analyzer using a swage lock or similar kind of connection. So very, very simple in concept, but quite complicated in practice because you're working at ppb levels in some cases, so you have to seal it very carefully. So the capabilities are relatively straightforward. We can generate test conditions from -100 to +10 frost dew point, which is equivalent to 0.01 to 12,000 ppmv of moisture content. And with this capability, you can test and calibrate any type of instrument. So it doesn't matter who the brand, manufacturer, or type is, you can calibrate it with the FPG. In terms of sort of the response time, so this graph shows you the time it takes the saturator to cool from an typical ambient dew point temperature of 5 degrees to -100. So we can go to -100 in approximately 1 hour. So that means when you set up the system, you usually do the lowest point first, and you can be at that condition in 1 hour. That doesn't mean you're ready to calibrate in an hour, because the sensors and the devices all have to equilibrate to the vapor pressure. So now you know what's coming next, right? It's like magic. Okay, but that's a typical response setup time. That's a typical test profile. So in this case, we have a sensor, a dew point mirror, and the FPG saturator temperature all plotted at the same time. And you can see that at -80, the sensor has been adjusted at -80, so it agrees very well. Then we go to -60, you start to see some deviation. At -40, it's a little bit worse. And as you get to the higher range, you've got a 10 degrees difference. And this is a fairly typical dew point sensor. They can be optimized for performing well in a certain range. So it's a way of identifying where that instrument is working very well. And as you can see here, we go -80 back to -80 over a period of about 500, 600 minutes. So 10 hours, you can do a high and low calibration on whatever instrument you want to work with. In terms of uncertainty, we are specializing in calibration systems. That's our primary focus. So we always have to define the performance of the system in terms of an uncertainty with a 95% confidence at K=2. And with input from UCAS, our accreditation body, the Prometheo project, which I'll explain second, the MPL, we've been able to form a calibration picture, if you like, to give an expanded uncertainty, typically at -60 of 0.11 dew point. And now sensors have a specification usually at that value of about ±2, so we have a very good test uncertainty ratio for the performance of the system. I mentioned the Prometheo project, and it's important that we promote this. The European Union on the Horizon 2020 project ran a program across Europe, and we were very lucky to be part of it, even though we were kicked out or we left Europe. But we were able to work collaboratively with all of the network around Europe in specialty gas, sensor manufacturers, calibration labs. And they helped us finalize the development of the FPG and gave us a test capability. We had collaboration with sensor development companies and various other things, so we were able to really get a good confidence with the FPG thanks to this project. And the FPG was recommended after this project as an artifact suitable for intercomparisons. So we will send the FPG around to different labs, they calibrate it, and then everybody compares the results to see the equivalence. Which in the metrology world is a really useful and important thing that happens all the time. Okay, this slide, I mean, the impact of calibration and traceability has many different facets. If you want a good sensor performance, you need to calibrate it first. Every sensor has to be calibrated first, with the exception of, for example, the primary system, like a chilled mirror, where you have less need for calibration. But a dew point sensor or a moisture analyzer generally has to be calibrated. Okay, so every sensor needs that capability. Validation is now increasingly important in many different industry sectors, because if you have to give it a class 1 ppm gas supply, you have to be able to prove that it's that way. So you have to validate the measurement and calibration systems. ISO 17025 laboratories have to have measurement, traceability, and calibration. And of course, the efficiency effect, which is where we're really focusing with the FPG currently. And calibration costs can be very substantial. So as an example here, this is a real example from a real customer. We obviously are not going to say who it was, but they have about 50 dew point sensors on site. Okay, they're monitoring the battery production area, and they need to be sure that the condition is as a maximum minus 40 degrees of dew point. So they have all these sensors monitoring the conditions to verify that condition, but obviously from time to time they see some changes. Battery environments can be a little bit critical for dew point sensors, so they check the sensors every 6 months. And what we were able to establish was that the typical cost for a dew point sensor calibration for this customer was $850, okay, including the transport there and back, not including the time for the engineer to take the sensor out and put it back and replace it with another sensor. So the annual cost for this particular one battery production customer was $42,500 per year for calibrating their dew point sensors. The cost of the FPG was around $55,000 US, so the return on the investment was just over 1 year, which is pretty good justification for investing in an instrument for calibration. But even more important than that, from the battery production engineer's perspective, they have an instant possibility to check a sensor. So instead of having to wait 3 months for the sensor to be verified at the factory, they can take the sensor out, put it into the FPG, and they can check them. So they then know which sensors are working good and which ones not. And that is a real example. Nearly finished, you'll be glad to hear. I mean, the applications for the FPG, we launched it in 2023, and we found that the market for it was not as we expected. We expected the sensor manufacturers to be really interested, but actually they're really afraid of it, because we can see now how good or bad those sensors are very, very easily. So we've gone more directly to the calibration laboratories, who need methods for calibrated dew point sensors, and moisture instruments. Battery production is a very, very typical end customer. Compressed air systems, natural gas, the ones I mentioned earlier. So we're finding very good uptake from industry customers where they can do the calibration now on-site themselves with a relatively modest investment, with many, many benefits from a quality and a financial perspective. Okay, I'm nearly done. So, launched in 2023 at the SIM conference in Paris. We've had really, really interesting sort of 3 years of developing, fine-tuning, and it's really now at the point where we're kind of looking to expand very much into the global market for humidity, because we really think this will help people to do better metrology, better measurement, and dryer efficiency and such like. Okay. Oh, there. And then it's changed there. So, and it's available now. We're on stand 1-645, just over there, next to our other humidity friends. And we'd be very happy to show you the system before I go home this afternoon. Okay, that's all I have to say. Thank you very much. Oh. A little fast.
Well, thank you, Robin. You've been pretty fast.
Yeah, sorry.
So, no problem. No problem. So we have plenty of time for questions. So I think it was an interesting example on how important calibration is. Always have in mind there's no serious measurement without calibration, and I think it was a good example also that calibration could be very cost efficient and work. So we have a question from Dr. Stefanelli.
Yes, I have a question about the economic aspect.
Yes.
You told us that we save a lot of money if we use to calibrate our devices. How much costs it to calibrate these devices?
To calibrate the FPG?
Yes.
It would be around about the same cost as calibrating a dew point mirror or a reference standard. So, depending on your supplier, but typically around 2,000 euros every year or 2 years.
Okay.
So it's the same as having a calibration reference instrument. You can calibrate it by comparison. So about 2,000 every 1 or 2 years.
Okay. Thank you.
Okay.
More questions? We still have time. No problem. By the way, may I ask if our next speaker is already here? One. So maybe you can approach our technician and get your headset and... But we still have about 10 minutes or so to go, no problem. So if there are no questions, I think Robin will be happy to welcome you at the booth. Number was 645. It's not too far from here, I guess. So, yes.
Just over there.
Right there to the left. So if you have more questions or you want a demo or see the instrument, then just go to the booth. So we have to wait another couple of minutes. Please stay. We will stay with the topic, actually. It will still be frost and dew point calibration, the next talk, and even